Hi, I'm Eric Plumley, the Chief Technology Officer at Neurolens. So when we developed the NMD2 device, our primary objective was to make it smaller, make the test a little bit faster, and make it weigh less. In addition to that, we've added some additional functionality so that the graphics inside are a lot more realistic and it's a better overall patient and user experience. All right, let's go ahead and take a measurement. We'll show you how it works. So it starts off by measuring pupillary distance. So we're measuring pupillary distance now. And then once that's done, you'll see some different graphics show up, and it's going to measure a base alignment. So it'll show the target in one eye here, and it's looking at some disassociated graphics in the other eye. The system's looking for eye turn in the eye that's not looking at the target to determine what their disassociated phoria is. And that's the first portion of the test. Then it moves on to an associated test. So the patient now is seeing moving targets in the peripheral, in this case fish, and it's seeing the target alternate centrally between the left eye and right eye. Again, the machine is looking for any eye movement. If it sees eye movement, it will adjust the target position until it can neutralize all of that eye movement. Then the screen will go blank. It'll adjust the accommodative stimulus to cause the patient to accommodate. It'll also adjust target position to cause the patient to converge. And so then we're going to again measure pupillary distance at near to start so we know where to put the graphics. And then we're going to do the same thing. We're going to measure base alignment. Then we'll do the final alignment where it's the associated test again. And then we'll be done with the near measurement. All in all, the test should take about 2 minutes as opposed to the 3 minutes of the previous machine. So it's a much faster test. And one of the great things about this with the fish and the wider peripheral view, that the patient has a much more immersive experience in the device, that they really feel like they're looking into infinity. So here we go, we're done with the measurement. We got a distance in near. You can lean back, Chris, you're all done. Once you've continued, you get a summary of the measurement. So it'll tell you what your pupillary distance. Something new about the device is it'll give you a right and left, so it does monocular PDs for you. If you're using the monocular PDs, it's important that the patients index their nose on the nose index in the middle of the device. So you might remind the patient to do that. The other measurements, it gives you a horizontal misalignment at distance and at near. Typically, patients are more exophoric at near, which is why the contour prism and the neurolenses work so well in treating patients. It also gives you a vertical measurement, and it gives you some prescriptive guidance. There's a lot of information that's available to the doctor on the device that can help explain to the patient what's going on with their eyes. You can see how the system was tracking their eyes throughout the measurement, as well as identify the misalignment, so you can see the distance between these two lines. That's how much misalignment the patient has. There's other screens as well that are user-friendly that show where the patient's eyes want to be versus where they need to be. All this information is uploaded to the portal so that you can have access to it and explain to the patient what's going on with their eyes and why Neurolenses would benefit them. We're super excited to get the device on the market. I'm sure that doctors and patients alike are going to really enjoy the new experience.